Alright, so you've downloaded the Unity Hub, you've installed Unity, and now you're ready to get going, but you have no idea where to start. That's what I'm for. So after you've gotten one of the Unity installs, whatever version you have, doesn't matter, you can go up here into projects, a lot of tutorial projects, some actual game projects, and some experimentation projects. We can make a new project, and here we have a bunch of different templates. So if you want a first-person game or a third-person game, there are templates to work off of. Realistically speaking, if you're making a quick fun game and this is your first game, probably good to work off of one of these. We're going to, for this series, go with a clean, empty project, just because it'll allow me to show you all the functionality of the engine a little bit better. So with that, we have the option to go 2D, 3D, and then there's another 2D and 3D. What is that all about? That's got to do with the different render pipelines that Unity provides. For this tutorial series, we're going to make a 2D URP project. So we'll select that, and then we'll call this project Learning Unity. You can give it a file location and then create your project. And once your project opens up, you will see this. We're going to go over the main bits of this UI before we get into what Unity is and how it works and what game objects are, how to make scripts and how to program and all that kind of stuff. We're going to take this one step at a time. So the first thing you might see here is your scene view. This is where you're going to be building your level. So anything that you put into your game, you're going to put in here and you're going to be able to see it here. Then in the same window, there's a little tab here that shows you the game view. This just shows you the view from your main camera, which is the rectangle that we can see here with the little camera icon here in the middle. So if we click on that, we can also see the main camera view in the bottom right corner here. That'll also show you two things at the same time. Number one, a lot of information here in the inspector. We're going to skip over that for right now. We'll get back into that in a minute. You'll also see that here in the hierarchy, suddenly this object is highlighted called main camera. So if we click off it again, you'll see the main camera is no longer highlighted. It also works the other way around. So if we here in the hierarchy click on the main camera, we can see in our scene view that then selects the main camera. So these two things are linked together. This scene view is the visual representation of everything in your level, in your scene as it's called. The hierarchy is just a list that shows you all of the objects in your scene. Then coming back to the right side of the screen here, the inspector. This is one of the most important windows in Unity because what you're seeing here in your hierarchy, these are different game objects. And game objects are the foundation of how to make games. These are the things that exist in your game world. Those game objects can be a lot of different things. A game object can be a light, it can be a camera, it can be the player character, it can be an enemy, it can be a boss fight, it can be a non-visible thing like a manager for managing information flow between objects. Everything in your game is a game object, and different game objects are built out of all these different things here called components. So this main camera component has a transform component. Every game object will come with a transform component. It needs a physical location in your world in order to be a game object. Then beyond that, this one also has a camera component and a audio listener component, and then the universal additional camera data component, which is a script. And we can open and close these components when we need to work with them, and we can add our own components to this as well. So we've got the add component button, and there you can see there is a bunch of different submenus. And let's say we want to add a physics object to this camera so that the camera follows the laws of physics. Something you probably don't want to actually do because that means that the camera will be affected by gravity and it'll always fall to the ground. But you can click on this little arrow here, and here we get all of the different physics related stuff, which includes colliders. So if you want for some reason to have a camera that can't pass through a wall, this could be a way of doing that. It's not the best way of doing it, but you can give your camera a collider. Or a rigid body, which is a very important type type of component that you will be able to use a lot in the future, because rigid bodies tell the engine that, hey, this game object that has this component in it is going to use physics. So it's going to be influenced by gravity, it can be pushed around by other things that have colliders, and so on and so forth. So that's the main breakdown here. We've got our scene view that's filled with game objects, and those game objects are built up out of components. Then you've got your project down here, and this is just a folder structure that will show you all of your assets. So the root folder here is called assets, and by default it comes with this scenes folder as well, which holds a sample scene and then some setting objects, which we're going to ignore for now. And if we just right click in here, we can create, and we can create a bunch of different type of things. So just to show a little bit of how Unity works, we're going to make a game object now with a sprite, and we're going to add another component to it. So what we'll do is we'll go in this create menu into 2D, a sprite, and we'll make a square. That's just a default sprite that Unity comes with. It's just simply a white square, very small, but it works fine. We can just drag this into our scene view, and as you can see, we suddenly see the square in our scene. We also see that it added the square to the hierarchy, because as we've discussed, these two things are linked. This is simply a list of the things that are in here. And since it's a game object, it's always going to have a transform component. And we dragged in an image, so Unity is smart enough to understand, oh, wait a second, this is a sprite. It's a 2D sprite, so I should add a sprite renderer component on my own with all of the required fields already filled in. So it knows that we dragged in the square sprite, so it's going to be rendering this square sprite. We can very much change this if we want. If we want to change this now to instead use, I don't really have a lot of sprites here, but the OK, it's changing the sprite. So you're not limited to the sprite you initially import. But no, I wanted to actually have the square sprite, but I can't find it in this whole list anymore because this list is very messy and very, very long. And maybe if I just search up in it, okay, we can find the square again. But there's actually a much easier way, and that's as long as we have this square game object selected, we'll have the inspector open, and we can just drag in compatible assets from our project files into the fields that support them. And suddenly we're back to having our square in our sprite render. There's some options here as well. Changing the color. This will just tint the existing sprite into a different color. So if you have got a black and white sprite, it will add color into it. If your sprite already has color, it will get tinted with whatever color you're adding to it here. We can flip sprites in the X and the Y. There's a couple of different draw modes that we're going to skip over for now because that's not really relevant and a bit too complex, and the same really goes for most of what's going on here. It's not relevant for what you're learning right now. Now, we've added something into our scene view, and actually let's make this color green instead, because otherwise it's not going to stand out against the background color of the game. Now, we've got a object in our scene view. It's within the camera's bounds because this is what the camera is seeing. As you can see, we can see the little green player thing that we've put in right here. If we want to play our game, we can come up here and press the play button. That will run the game and automatically switches over to the game tab. And now our game is running. Nothing's happening because we have no functionality on any of these things, but this is the game running. We can stop the game from running by pressing this button again, or we can actually pause the game, which will take us back to the scene view, where we can inspect some of these objects and maybe see what's going on with certain values, or for debugging purposes, this can be very, very useful. For now, let's end the game and add a component because we want to see something happen when we run the game. So what we can do is we can add a rigid body 2D. A lot of different components have a normal version and a 2D version. Since we're making a 2D game with 2D sprites, we're going to be using the 2D versions of these. If you're doing something in 3D, which I recommend if you're just getting started, stick with 2D for experimenting and learning the engine a little bit, and then move on to 3D. But if you're doing 3D, you use rigid body. Since we're using a 2D thing, we're going to go rigid body 2D. We can add that, and that gives us a bunch of different settings again, which once again again, we're not going to go into detail about every little setting here because that's going to give you information overload and it's not really necessary to understand all this right now. All that we need to know here is that we've got a gravity scale, which let's set that to 0 for the time being. If we run the game again, nothing will happen because our gravity scale is set to 0. But this is where things get interesting because on runtime, while the game is running, we can change this value and the game will respond to it. So if we set this gravity scale to 1, we'll see that the block is going to start falling. And there we go. What's more, you can see now that we've stopped playing the game, our gravity scale is set back to 0. So any changes you make during runtime, during gameplay, will not actually carry over into your project as it is. So that gives you the opportunity to experiment a lot with different settings and different values in a lot of different things. And if you do like what you have made, so let's run the game again, you can set this to 1 and you're like, okay, yeah, that is a good amount of gravity. You can actually right click on a component and you can copy the component. Then when you're back in your scene view, you can right click that same component again and we can actually paste component values. So this way we can take what we've made during runtime, copy it over and paste it onto our components in the scene view. And there is a bunch more windows that we could go through. The last one I want to mention for today is going to be our console window. This is where you will see any errors popping up. So if you are making your own scripts, which we'll get into very, very soon, and something isn't working right, maybe a calculation is going wrong, or maybe a variable isn't being set properly, or something doesn't have a value, well, it should. That's all going to be logged here for you to figure out what's wrong, where the mistake is happening, and for you to go fix it. Up here in window, we have a bunch more things like our general windows, our rendering related windows, animation, audio, sequencing, analysis, our 2D stuff, our AI stuff, our UI toolkit. There is a lot. Way more than you should be getting into at this point. Alright, it's time to get to learn about programming. If you don't know anything about programming, you've come to the right place. I'm going to go over programming in C# for Unity at a very basic level today. If you've seen the last part of the series, you will be familiar with the UI. If you haven't seen the last part of the series, you don't need it to understand here. We're going to specifically only be talking about programming parts. So let's remove this square real quick because we don't really need this. What we're going to do instead is I'm going to make a little UI element. And we're just going to add a legacy text for the time being. And don't worry about how the UI system works for Unity. We'll get into that more in detail later on. I'm just going to make this text a little bit bigger so that it's easier to see. And then we're also on this same canvas going to add a button, which will get a window up with a TMP importer. We imported TMP Essentials. TMP stands for Text Mesh Pro, which is the preferred method of using text in Unity. For now, we're not going to dive too deep into it. Again, that will be part of the video all about UI. We can make this button a little bit bigger, put it somewhere up on screen. But now what? Because we want to, when we press this button, change this text. But how do we do that? We're going to select the text and we can see it's got a rectangle transform, which is a little bit different from the usual transform. But again, not too relevant. A canvas renderer, which just tells the engine, hey, this is a UI element. And then the actual text that we're seeing. So we can change this text to number 0 and we can see it's 0. But now how do we change this number through code? And the way we do that is we're going to add a new component. And we've already seen what we can do with components. We can add rigid bodies to them to make them fall through with gravity. But it would be really limited if you could only add components that Unity provides you with. So what we can do instead is we can just type in something like text updates and we see, oh, it doesn't have any components for that, but it does give us the option to make a new script. So we can press on that. It automatically picks the name that we were looking for and makes that the name of the new script. So we can create and add, and now we have the text update script on this text object. I can also see down here in our project, we've finally gotten our first script made. So we can double click this and it will open your code editor, whatever it might be. probably is going to be Visual Studio. And here we have our first bit of code. This is the template of all your scripts that are going to be made in Unity. Going to start by these 3 lines using System Collections generic, and Unity Engine. Then is going to say public class and then the name of your class, the name of the script, and it derives from mono behavior. This just means that everything that the mono behavior script, which is all the functionality that Unity provides you, everything that's in mono behavior will also be accessible in text update. You can also do this for your own scripts eventually. So let's say you make a player script, but you have 3 different types of players. You can then make player 1, player 2, and player 3, which would be the individual classes, all derive from your main player class, which then derives from mono behavior. So that is to say that all those players won't need individual programming for everything that they need to share in functionality anyway, such as moving around and jumping and maybe like shooting. Next up, we have a comment. These things in green, they start with 2 slashes. These are not code. These are things that the engine is going to ignore while running the game, but will be useful for you as a programmer to be able to read, hey, this is what this is doing. Hey, this is where this functionality comes in. Then we have our first actual function. It's a void start function. This is a function that Unity provides you with, and a start just runs once when the game object is put into the world. The first frame that the game object exists, every bit of code you put into these 2 curly brackets is going to run. Void, what that means we'll get into a little bit later on in this video. And then here we've got update, and as it says, it's called once per frame. So if your game runs at 900 frames per second, the code in here is going to run 900 times in a single second. If you run at 30 frames per second, it's going to run 30 times. And I will also give you a little bit of extra here, because that could be problematic, right? If you want to do certain things as far as like movement physics go, you don't want them to be dependent on the frame rate. So what you can do is you can make a new function that Unity already has made for, and that is the fixed update. So we can do private void fixed update. You don't actually need to specify private. If you don't specify anything, works the exact same way. And fixed update will just always run 100 times a second. So if you need something to do with physics calculations and stuff that needs to be frame rate independent, because you don't want your character to be able to run faster if you have a higher frame rate, right? You do it in fixed. All these 3 things are what we call functions. And a function is nothing more or less than a list of instructions. So think, for instance, we want to move our character left every frame. Then in here we would just say move the character left, right? Of course, that's not how coding works, but then every time this update function is called, it will do whatever it says in here. And as we know, this update function is called every frame of the game. Now, aside from functions, which are a list of instructions, there's one other fundamental thing that you're going to need to understand about coding, and that is variables. There's a bunch of different types of variables. We're going to go over the most useful and most common one. In contrast to a function, which is a list of instructions, a variable is just a container for information. So we've got a bunch of different types of containers that then hold different kinds of information. So one of the most important types of information that you can have is a bool variable. And a bool variable is just a true or false. So a bool variable is a container for a piece of information that can either just say yes or no. There's no in between. There's nothing else in there. It can be yes or no, true or false, 0 or 1. Then we've got integers, which you're probably familiar with integers because those are just whole numbers. So let's call this integer number. So that's 1, 2, 3, 4, 5, 6, all the way up to like 44 billion something. And these can also be negative numbers. So we can have an integer that is negative 25 or positive 36 or whatever you want. An integer, however, cannot have a decimal place. So if you want 1.5 or 9 3/4, if you're a Harry Potter fan, that's not going to fit inside of an integer. For that, we're actually going to need a float, and those can have decimal places. So if you want 1.358796, for instance, which is a random string of numbers that have decimal place in it, you're going to need to use a float. For the most part, I would like to say don't worry about the difference between an integer and a float, because it's a negligible difference as to what you use at what point, and integers are rather constraining. There's certainly reasons to use integers, which we'll get into in like a lot of different other tutorials where we actually use integers. But for the time being, just think if you need a number that's actually going to be used in some kind of math equation or some kind of functionality, it'll have to be a float. If you need a number count objects, use an integer. That's kind of the main distinction between the two of them. And the last one that we're going to be talking about right now will be a string variable, and that is just text. So if you want to have your player name, for instance, that's going to be stored in a string variable. If you want to have the name of a weapon, that's going to be stored in a string variable. There's a lot of different things that we can store in a string variable because any type of text is a string. And with these 4 types of data that we can now put in these 4 types of containers called variables, you can pretty much make whatever you want if you're creative with them. There's a bunch of different other types of variables as well that we're not going to be worrying about for the time being. These are the 4 most important ones. So let's go over real quick what we've talked about so far. We've got our script file, which contains this class. In that class, we have variables and we have functions. The variables contain information, while the functions execute instructions. Unity comes with a lot of pre-built functions that you can just make and it'll know what it's supposed to do. You can make your own functions as well, which we'll get into a little bit later down the line. The start function runs once when an object is created. The update function runs every single frame of your game. So that can be a really variable amount of time. Could be 1,000 times in a second, could be 10 times in a second if you have a poor frame rate. The fixed update function is frame rate independent. This will just always run 100 times a second, no matter what happens. Now that we know that, let's start making a bit of functionality here where we have a variable that's displayed as the text that we just added to our UI. So let's delete these 4 variables that I've made, and we'll instead make a integer and we'll just call that the number. In general, it's good form to start your variable names with a lowercase and your function names with a uppercase character. It's not technically needed, but as you go along and you're referencing other scripts all over the place, it's very nice and easy to be able to see, oh, that's a uppercase something, so that's going to be a function. Or that's a lowercase something, so it's a variable. Anyway, we've got our integer, our number, and we've got our updates. But what are we going to do now? Because can we make a text? We actually can, but you can see something weird happens up here. And that is because these using lines aren't just for show. By default, your scripts won't be able to allow all the functions and all the variable types that exist. That's just an optimization thing. A object that has nothing to do with the UI doesn't need to know how to influence the UI. And if it doesn't know how to do that, it's going to make it more heavy to run, and you don't want that. So purely an optimization thing, but we do want to influence the UI because this is a text on the UI. So what we'll do is we'll say using Unity Engine.ui, and you end every single line in your code with this semicolon. You can see them up here as well, and I also put them after this number, as you might have been able to see. Semicolon just tells the code, okay, this is where one of my commands ends, so that it knows where the next one starts. A simple enter will not do that for a variety of reasons. So now that we've added the Unity Engine UI, as you go along with coding, you will start learning when to add these. And as you could see just now, since I'm using Visual Studio, it also knows that, oh, you're trying to add a text, but you can't yet because you need Unity Engine UI. So you'll learn this as you go along. Anyway, we can make a text with a capital T, and we'll just call that text with a lowercase t. And now we have a text variable as well that we can actually influence. So we'll go to the update function because we want to make sure that this always on every frame updates to reflect the value of the integer that we have just made. And we'll say text dot. And now we get all of the possible things that we can do with a text variable. So you can see there's a lot of different things here. And you can just look through this if you're interested. But really what we're looking for is just the text. So text.text, which is the string that it will display, is equal to, and now it requires us to put in a string. Let's put in our number and a semicolon because that's the end of the command, but there's an arrow line under that. Just because we as humans understand that a integer as a number can be written down doesn't mean that the computer understands. So we need to tell this that use this number and put it in a string because it's expecting a string. So we can't just give it an integer. Luckily, it's very easy to do that with most types of variables, if not all types of variables. You can simply add a dot and then toString with 2 parentheses at the end. And now it will take the value of this variable and put it in a string. And that will then be displayed as the value for our text. You'll note that the end of this needed 2 parentheses, and that's very much like the functions that we're seeing here. And that is entirely correct because toString is a function. It's a function that exists within the base of C#, really, within the integer variable itself. So surely that's it, right? Now this should work. So if we go back into the Unity editor, now we can just go into this. We have the text updates and this should work. Well, not quite. Because number one, this text doesn't know which text it's talking about. There is a container here to have text information and be able to influence and change that, but it doesn't yet know specifically which text. There's a container, there's just nothing in it. We need something to point towards, hey, this is actually the data that we're going to be working with. And we can do that in a number of different ways. For the time being, since these are on the same game object, the best way to do that is to come up here in void start, which will run at the start of the game, and just say that our text is equal to getComponent text. This will look at the same object that this script is placed on and see, do I have a component of the type text? If so, then this variable will be set to that specific component on this specific game object. You could very well have 10 different game objects with all different types of text on it. So you need to show every single variable which version, which actual component on which actual object it's referring to. But we still can't increment this number at the moment because we've got this integer number which doesn't have a value yet. So by default, the value will be 0. We can't update that. So let's do that. We'll get rid of this fixed update because we're not actually going to use it. That's just there to show you. We're going to make our own function. It's going to be a void function and we'll call it increase number. And here we will put in the functionality that we want to happen to increase our number. So we can get our number and we can set it equal to being number plus 1. So it'll always take whatever value our number is and add 1 to it. So if our number is currently 20, when this function runs, it's going to become 21. If we've got 999 in our number and this function runs, it's going to become 1000. Now, there's 2 different ways of writing this specific command here, and I'm going to go over both of them. If it confuses you, don't worry about it. This is an entirely valid way of writing out increasing a number. We can even say increase it by 6 if you want, or increase it by 86, whatever. So, but if you just want to increase it by 1, instead of saying number equals number plus 1, what we can do actually is we can just say plus equals. This does the same thing. It will just add whatever is on the right side to whatever is on the left side. So this still allows me to add 15 if I wanted to, instead of just 1, or 23 if I wanted. But we want to add just 1. So another way to do that is to just put in your integer and put plus plus after it. There's a little shortcut, plus plus incrementer, which will just add 1 to whatever integer or float you're using it on. For now, and for ease of use, we're going to stick with number equals number plus 1. And I think now is a good time to dive a little step deeper into functions. Because why are these parentheses here? You might have been wondering this for the past however long this video is. And that is because you can put parameters or argument in here. And you might be wondering, what is that supposed to mean? You can put variables in the function itself. well. So we put some variables up here at the top of the class, which means that everything in this script is going to be able to use these variables. But in this case, I want to make a parameter in my function, which is a variable that can only be used within this function. So the way we do that, within the parentheses, we put in an integer, just like we would do for any other variable, and we say number to add. Then instead of just adding 1, we can use that as a variable, and now we can call this function and we can say we can add 1 to it, or maybe if we press a different button, we'll add 5 to it at once, instead of having to make a different function for add 1 and add 5 and add 10 and add 50. And you'll note that if I want to use number to add in the update, so let's say that number is going to be equals to number to add, that doesn't work because number to add doesn't exist outside of this function. This function is the only place that number to add even exists. So let's get rid of this just because it was for showing you. Usually the way that we differentiate that is putting an underscore before the variable. That shows you it's local to that specific function. And now the final thing that we want to talk about for the time being is you might have seen the word private appear in front of this. And a function or a variable can be one of two different types of accessibility. That being private, meaning that only other things within this class, so everything within these two curly brackets up here and down there, will be able to use this function. But if we go to another game object and make it look at this script, everything that's private, it won't be able to see, it won't be able to use. So if we have a private function, the button object that's in our game will not be able to use this increment number. And it will need to be able to use it because pressing that button is going to increment the variable on this object. So instead of making it private, we can make it public. And a public function or a public variable can be seen by other scripts on other game objects. I'm also going to make this integer public just to show you that variables can be public too. And we could influence this from another script if we wanted. But more importantly, making a variable public will make it accessible to you in the editor. We still got this void thing going on here. For the time being, we're going to leave that alone. If you are interested in looking up for yourself what that does, void is the return type. You can make functions that return a value. So this could be a function that takes in a value and then puts back out for instance, an integer, right? Or a bool. This function, however, doesn't do any such thing. So if a function doesn't put a variable back out and just does some functionality, we call it a void because its output is void. It's nothing. It's 0. Again, not particularly relevant right now. So if you don't really understand what I mean by that, don't worry about it. We'll get to it at some point later when we get into a couple of steps further into beginner programming and maybe moving towards intermediate-ish programming. For now, just know that if you're making a function, it's going to need a return type. And for the time being, that's pretty much always going to be void. Finally, we are back in the Unity editor. And as you can see, we made the number a public variable. So now we've got a little field over here in which we can put in the number. Of course, the game isn't running at the moment, so the number in here doesn't change. But if we run the game, we can see the number here is 50. And if we change it to 60, changes to 60. And now to 80. And so on and so forth. So let's put it back to 0. Because what we want to do is we want to have this button over here. When we click it, increase this number. A button comes with a on-click event. So we can add something to this list and it will ask for a game object. So it'll be looking for a specific object that is going to pull functionality from. For us, that's going to be this text object that has our text updating script. So we can pull that into this field over here. And then this drop-down menu becomes available. At the moment, it's doing no function. So we can click on that and we can go to our text update script, the one we made, and we'll see a bunch of different functions that Unity just automatically puts on this kind of game object. But most importantly, we can see the increase number function that we've made ourselves, and it shows you it takes in a integer. So we select that one and then we say we want to update this by 1. Now if we run the game and we press this button, we can see it updates our number by 1. But if we say, actually, I think this button should probably update this this number by 5, we can just change this value in the on-click event, and now it's adding 5 to it every single time we see it. And of course, the next logical step there is having this button increase the value by 1, and then having the button selected and pressing Ctrl D will allow you to duplicate it into a new separate game object. So we can just drag that down. We've got 2 buttons now. And on this button, we can say this one is going to increase it by 5. So now we've got a button that increases by 1, and we've got a button that increases by 5. So we've got this button increases by 1 every single time we click it, and this button increases by 5 every single time we click it. I know that was a lot of information, very information dense, and if you're very new to coding, it's going to take a little bit to wrap your head around all of this new information. I wanted to keep this as entry level as possible because it's difficult enough to get into as it is. As we go along and as you figure out other type of things that you want to make, and if you figure out, oh, I should be watching this tutorial for this function or whatever, you will start to build up your knowledge. It's very much a matter of once you understand these basic ideas that I've explained to you here today, from here on out, it's building your knowledge of what tools you have accessible, what types of variables exist, what type of built-in functions exist. To make a game, you need to make sure that your player can actually input actions, pressing keys to make your character move and attack and jump and dodge and whatever. So let's talk about Unity's input system. There's 2 options that you can go with. The old legacy system, which is what's enabled by default when you make a new project. I have an entirely separate video about using that system to make a character controller, so go check that out if you want to. Today we're going to be talking about the new character input system because it's better, it's more flexible, and it's probably what you're going to be using, especially moving forward into the future. So first things first, to enable that, you'll come up here to Window and open the Package Manager. That will open up this over here. And probably by default, your packages will be set to being in project. So that will show you all the packages that currently exist within your project. We want to add something that's not in our project. So instead, you should switch over to Unity Registry and then scroll down until you see Input System. I already have it installed, but you just simply select it, and then where it says remove here, for me, it will say install for you. It will prompt you with a pop-up saying, hey, you already have the old system enabled. We'll have to restart the engine and disable the old system if you want this to work, which is fine because we're not going to be using the old system. Now that the engine has restarted, we can put that new input system on a player. But before we can do that, we actually need a player. In our hierarchy, let's just make a new 2D object. Let's make it a square and let's make it, I don't know, yellow, the fun color. This will be our test player for the time being. So we're going to add a component to that, and that component will be a player input component. Needs a couple of things. Everything down here we can ignore for right now. What we need is a input action asset, which we don't have, but luckily we can create actions which will just provide us, we can just save that, with the default things we need. So that's moving, looking, and firing, and then also some UI related stuff that we're not going to get into right now. You can make as many of these actions as you want, and under every action you have the inputs that corresponds to that action. So for moving, we've got let's go with WASD, which also has the keyboard arrows in it. If we go into the up key, which is W, we can see that the composite part here is set to up, and the up arrow is also set to up. S is set to down, and the down arrow is set to down, and so on and so forth. This information will be converted into a vector 2, which in the next video we're going to get deeper into different variable types and what vectors are and how to use them and how they work. But for now, just know that this vector 2 value has 2 numbers in it, an X number and a Y number. So if we press up or down, the number corresponding to up and down will change. If we press left and right, the number corresponding to left and right will change. If we press both at the same time, both numbers will change. Might sound a little bit abstract, so let's actually use this very thing as the example that I'll show you how it works with. So coming down here, we're gonna open up the console real quick because we're gonna be using that to show off how these inputs work. But before we make any scripts script to make use of this, I want to pull your attention back towards the player input components, because we've got a couple of different behavior types that we can use. We can send messages, we can broadcast messages, we can invoke Unity events or invoke C# events. For the time being, we're going to just stick with sending messages because it's the most straightforward out of the bunch. And you can see this will send messages, which just work as functions, more or less, or events, to the game object that this is on. So we've got on device lost, on device regained, which is really useful, so you can actually execute code when people unplug their controllers or something like that. But the more important ones are on move, on look, on fire. Because if you notice, move, look, and fire are the actions that exist over here. And if I make a new action myself, and I call it test, for instance, and I save this asset, you see this list updates, and now it also has on test. So if we look for any of these in a script that exists on this game object, whenever any of these inputs happen, we can execute code. I'm going to delete the on test because we're not actually going to use it. And let's make a script to show you how that works. So let's call this script player movement, because eventually that's what this is going to turn into. So we want to be able to see our input for movement, right? So what we do is we make a new function starting with void, as we've learned, and we'll call this onMove. It needs to match exactly with the message that the player input system is sending. So do be mindful of that. We also need to be using a new namespace. So we'll be using Unity Engine dot input system so that we can actually use the variable types that come with the inputs. The most important one of that being the input value, which is a variable type that holds the input value. This can be a lot of different things, as we discussed before. The movement is a vector too, which means that it holds two numbers, but it could also be a bool or a trigger or something like that, right? Let's just call that value. And if you want to test something out without necessarily having to program any functional code, we can use the print function that Unity comes with, and we can just print out the value. And that's it, right? Well, not quite. Let's see what this prints out. So in our console over here, when we run the game, first and foremost, you'll see nothing happens. So when I press the arrow keys, so this will be the left arrow, it prints out Unity Engine input system input value. And when I let go of it, it still does that. And that's because it's not printing out the value inside of it, it's just printing out the reference to the variable itself. So we'll get a little bit more into this in the next video. Again, after value, we're going to place a dot, and that allows us to get access to one layer deeper into the variable, because this variable holds a lot of different functions, variables in and of itself. We're going to be looking for a function called get with the little spiky arrow things and parentheses after it, because you need to end every function with parentheses. And we're going to be getting the vector2 out of here. So now it will actually print out the two numbers that correspond to my input. So now if I press the left arrow, you can see that prints out -1, 0. -1 because I'm going left, and 0 because I'm not going up or down. If I now add pressing the up button to it, you can see it's -0.71, positive 0.71, because it automatically normalizes into always being fair with diagonal input. Especially for movement, if you would make this 1-1, that would technically mean that you travel faster diagonally than horizontally, which doesn't make a lot of sense. So it automatically compensates for that, which is really nice. What you also might notice is that it only updates when I press a new key, or as you'll be able to see, when I let go of keys. So that onMove function, that code, being triggered through the message and from this component over here, only fires when the actual value that it holds changes. It's not like update where it goes every single frame, because in the old system that Unity used to use, all your inputs would have to be checked every single frame. And while behind the scenes it of course still does that, you as a programmer don't have to worry about that anymore. But just printing out a couple of numbers into this console, which the player will never see, doesn't strike me as particularly useful, does it? You would be right. But now that we know that we're getting a vector2 value, even if we don't quite understand what that is in its full tool, we can make a new vector2 and call it something like dir for direction. And we know that we can set this because it's a vector2 as well. So we can just set this to be equal to whatever our last input was. So if we are not inputting anything, this will be 0, 0. If we're inputting left, this will be -1, 0. For putting in the up arrow, this will be 0, +1. And then when we let go again, this will go back to being 0, 0. But in order to use this to move around, we're actually going to need to go back into the engine real quick, and we're going to need to add a new component. And that component will be the rigid body 2D. We talked a little bit about rigid bodies before, I believe. This is just a component that tells this square, hey, you have gravity and physics in general. So we can now apply forces to it, and we can influence its velocity and that kind of stuff. And it comes with a gravity scale as well, which we're going to set to 0 because I'm just going to make top-down controls, since those are by far the easiest to do. But now that we have that, we can actually make a variable for our rigid body 2D. You can always make a variable for the rigid body 2D, but we need to be able to give it a value. So let's give it the name RB. And then in our start function, we can say that the RB equals get component rigid body 2D. So that is this variable, RB, is going to look for a rigid body 2D component on the game object that this script is attached to. If it finds one, now this variable is going to point towards that component, and that's exactly what we want. Then in our update function, we'll just set our RB.velocity to be equal to our direction. And now our inputs actually let us move around. It's really, really slowly, but we can move around and it's almost like a real game. From there, obviously, we can make a public float for something like speed. And we can simply multiply the direction with that speed variable. So now if we set the speed to 5 in our player movement here, you'll be able to see that we're moving around 5 times faster. That is basically the input system for Unity. There's a lot more depth to it. There's a lot more trickery and weird stuff that you can do. Okay, I wanted to make this into a separate video because it's very theory heavy. It's going to be very info dense. So I want you to be able to easily watch through this a couple of times afterwards if you need to go back to it. Vectors and more complex variable types. In the video where we started the introduction to C# scripting, I talked a little bit about floats, ints, bools, and string. I've got a float right here as an example for the speed for our character movement, and those types of variables, you'll note, have a different color, first and foremost, from the others here. These are light blue. This one is dark blue. That's because the dark blue variables, like float and int and string, exist within C# itself. The light blue ones are the ones that are added through Unity or through your own script. And those basic variables really only hold one bit of data. One number, one true-false state, one whatever. When we get into the variable types that Unity provides you, things get a little bit more complex. So let's start with the vector2, because unlike just having a float, if we look at our speed and we put in a dot, which I talked about this a little bit before, when you're referencing a variable and you put in the dot, it's kind of like taking the next step down a staircase, giving you access to a new layer of information regarding what you're looking for, specifying your funnel down from very broad, we're looking for this type of information within this context, and then this specific information. So in this case, if we're just saying speed, we're looking within the type float, and then there is nothing else in here except a number of functions. These functions you can use, like toString, it makes a string out of it, that's all fine and dandy. But if instead of speed, we go for our direction variable, you'll see that we have two variables within that variable. So this vector2 has a x value and a y value inside of it. So we can go for direction.x, and we can use specifically the x value from our vector2. If you ever want to look into a specific variable type and what might be inside it, you can just type it out and then right click and then go to definition. It'll take a second to look for where that definition is located. But here we see everything we can do with a vector2. Most of this is just different functions that the vector2 can do, but up here we see the actual content, the information that it can hold, the X value and the Y value, which both of those are just floats. And we know about floats, so a vector2 is nothing more or less than two floats called X and Y, and then a bunch of functions that we're not going to worry about right now. And in much the same way, you can make a vector3, so let's call that a 3 direction, something like that. And if we go look at the definition for a vector3, you will see it's got a X, a Y, and a Z component, and then a bunch of the same functions that exist in vector2, which again, we're not going to go over right now. And from there, the next thing that I want to talk about is the transform. This is a variable type that you will end up using a lot because it references the current position and rotation of any given object. So if we just try to write a line of code regarding our transform variable, we can see we can get the position out of that, and the position, I'll tell you right now, we'll check in a moment, is a vector3 variable. So that position we can break down even more into its individual components, that being X, Y, and Z. And this is the important bit to understand, is these dots are just a way to separate the different layers of focusing in on something very broad, that being everything to do with the transform. No, we're actually specifically looking for the position. Everything else that transform can do, very nice, we don't care about right now. And maybe we want to go a step deeper than that, and we want to specifically know the X position or the Y position, because maybe in a 2D game we want to see how far in the horizontal axis we are from a certain enemy to know if an enemy needs to do a certain type of attack, right? For that we need to transform position X or Y, depending on if you want horizontal or vertical. So let's real quick go into the definition for transform, and we can see that indeed in the summary the position is a vector3. Then we also got a local position, which has got to do with parenting, which again, just like this video, I'm going to make a separate quick video about parenting and how that works, so do keep up to date for that. For now, understand that you have these variables within variables that you can access, and that doesn't necessarily end with what Unity provides you, because in the start of this beginner series we've made this text update script. We can make variables with that, so we can say text update, and you see it works as a variable type. So let's just call that text. In our text update we have a public integer called number, so if we go into our text variable and we put in a dot and we look through this list, we can find number because it's a publicly available variable. So to put this into a more game ready context, instead of putting all your variables for your HP and your MP and your defense, if you're making an RPG for instance, on your character, you can make a separate script that you just call something like stats and put those variables in that script. Then that script can be used as a variable in and of itself on your player, but you can also use that, for instance, on your enemies and your bosses. And then from that stats variable, you can then get the HP and the MP and the max HP and all the information that you need out of that stats script. Let's do one more example, and then I think you should understand more or less what these vectors and these more complex variable types are all about. So let's go for GameObject, another one of the most used variable types you're going to be using. Let's just call it geo. So if we check geo dot, we have a bunch of information about this. But the most important thing there being is the thing we just talked about, which is transform. It has a position, it has a rotation, it's got a lot of different things inside of it. That whole everything about that is just one piece of what a game object is. So what we just did with going for our transform and then going into the position and then finding the X, we're doing the exact same thing here, but instead we need to first reference which game object it is, then go one layer deeper into its transform, and then from there everything is the same. Because if we go into the definition for game object, we can see in the summary it's got a transform. Now, understanding which variable types you need to use in which scenarios can be a very complex question, because a lot of the times it's very easy to just refer to the game object and from there find everything that you need, because anything that you're going to be referencing is going to have to be on a game object. Well, that means that you're making variables for game objects while you might only be interested in accessing the transform to begin with. And the same with, if you're only interested in tracking something's position, you don't need to make a full transform variable. A vector 3 or a vector 2, if you're making a 2D game, will do. But those are things that will become more apparent as you just play around and experiment with coding your own things. Once you understand the way that these variable types can have multiple bits of information inside of it, that's the most important takeaway from this video. I'm not going to go over every single variable type that you can find in Unity because there's a lot of them, and every single one of those variable types then has a lot of potential information inside of it. So if you ever want to know something, Unity has very good documentation on everything that is accessible to you as a game programmer, as a game designer. So just don't be afraid to look it up. Well, this has been rather information dense. Next time we're going to go into another thing that is decently information dense, but it should be a little bit more applicable to the actual game, and that is using all the information that we understand now. We understand variables quite a bit better than we did at the beginning of this video, and making something even more powerful. We understand variables now, but we're going to take the next step, because right now we only have place for one value in every single variable, and by and large that's good. But what if we want to make something that holds multiple values? Well, we can make a script specifically to hold multiple floats. That is exactly what vector 2 and vector 3 do. But what if we don't know how many floats we want to hold? Maybe it's variable, right? Maybe sometimes we want to have just 2. Maybe sometimes we want to have 5. Maybe sometimes we want to have 15. Well, there's a very good way to do exactly that. And for that, we're going to go over to this text update script that we've made before. This simply holds a number to display in the text in our scene. So if we go up here, it's this number has that script on it and it displays that number. So we've got this text and this number. We've got a function on it to increase that number. And what I want to do here is make this function have a couple of options. Right now, we're just putting in a single number and it's adding that number every time function gets used. But what if we want to add in a number of options like 3, 5, 8 and 9 and have it randomly pick one of those? What we could do is we could say public int number to add 1, and then we could add a comma, and then int number to add 2, and so on and so forth. At that point, we would need to make a version of this function for every single combination of how many numbers we want to add. We would have to make one with 1 parameter, and one with 2 parameters, and one with 3 parameters, and one with 4 parameters, and so on and so forth. And that's painful. It doesn't work very well. So what we can do instead is not making just an integer, but by adding simply these little square brackets, we're changing the integer variable into an integer array, which is just a list of integers. That's however long we want it to be. You might notice though that this bit of code is now throwing an error at us, because as soon as we made this into an integer array, we can't just refer to it as a normal integer anymore, because right now it's looking for an index. Every entry you have in an array called an index starts counting at the number 0. So we need to specify which index. So for now, we'll just call that index 0. There's a little issue with Unity where it can't use on the buttons, on the on-click event, it can't actually use functions that take in parameters that are arrays. So that's bad for my example. This is also a valuable lesson. This is not what I intended it to be. I foolishly didn't experiment with this before starting to record this. I'm going to leave this in because you're going to run into this quite a lot while coding your own games. Is you have an idea, you try it out, and you figure out that, oh, actually there's some weird reason that it doesn't work. And you're going to need to change course and be creative about, okay, if it doesn't work in that way, can I find another route to the same end? There isn't one solution to any given problem. There is infinite solutions to all of your problems. It's always going to be a trade-off between how easy and fast it is to make, how flexible it is to build off of for other functionality potentially, and how computing intensive it is. None of that matters right now though, because we're just going to change this around a little bit. So we're going to get rid of the parameter in the function itself, and we'll just make a integer array as one of the fields. So we'll make an integer array and we'll call that numbers to add. And then in increase number, we'll just use numbers to add, and for now, just to show you, we're going to stick with index 0. And let's also make this a public array so that I can show you in the editor what the difference is between the normal integer we have here and the integer array that we've just made. So we're now on the text itself, and we can see the number as we've used before. It's 0, which matches what we see here. But then we've got the numbers to add, which is a drop-down menu. And when we press this plus thing, you can see we're starting to make a list of different entries here. So we can say 5, 8, 12, 212, that works as well, 7, 3, 1, and suddenly we've got this list going on here. Let's actually make this 12 instead of 212, because that's a little overkill. Or maybe we want to just have 3 entries and we just want to say 1, 3, and 5. That is the power of an array. It should be noted that while I can add as many entries into this array as I want in the editor, I can't on runtime while playing the game add more indexes to an array. That's what lists are for, which we'll get into a little bit towards the end of this video. So now if we press these buttons during gameplay, we can see it's still adding 1, but that's because element 0 is set to 1. So if we set element 0 here to 5, now it's adding 5 with every click. But that still isn't particularly useful because we're still just adding element 0. I want to randomly add element 0, element 1, or element 2. Or if I have 6 elements, I want to randomly add one of those 6 elements. Well, we can arrange that. So we make a variable for the index instead. So we can make an integer and that is called index, which will be equal to random.range. And this will give us a random number between 2 values. So the lowest value will be 0 and the biggest value will be, what will that be? Because that changes depending on how long our array is. Luckily, we've got a function for that existing, and we just go our numbers to add array dot length. You might get this issue as well, where random is not recognized because both Unity Engine and System have a randomness function. So we're going to get rid of this using system that every script comes up with here. And that should fix the error. Now, instead of using index 0 always, we can put our index variable into our array index here. And now it will take a random integer between 0 and whatever length our array is, use that as the index for which number to add when we press the button. So remember, our array consists of 1, 3, and 5. When we press this button, it added 5, and now it added 1, and now it added 1 again, and that's 5, and that added 3. So we know it worked. We can, through this editor, add some more different ones if you wanted to. So we can see that added 15, and it added 3, and our code works. That's the most important part. But as I said before, you can't just like add more entries to this through code, because arrays have a set length, and you can't add something to an array. You can't just say numbers to add dot add and then add a new index to it. That doesn't quite work. If you want to do that, we make a public list instead, and then in those little pointy brackets you put in what type of variable the list will contain. In this case, it'll still be integers, and then you need to set it equal to a new list of that type, and of course you need to give it a name as well, and parentheses at the very end, because making this new list is technically a function, maybe something like that. Now back into the Unity editor, we can see this list here, and we can add indexes to it, and it seems entirely the same, doesn't it? Well, not quite, because unlike what we can do with the array that we have made, this list can actually be influenced during runtime. So we can say our numbers list dot add, and then we can add a new entry to that list. So let's just say 5 in this case. And now we'll see, let's make this list empty. Every time that bit of code runs, so every time we press the button, this list will get increased in its size with a new index that has a value of 5, as you can see. Something that we couldn't do through code with an array. Now, this is very, very powerful, but also it being able to do this means that it is going to take up more computing. So, as I said before, there's a lot of ways and a lot of options to do literally anything that you can think of. You're going to have to slowly learn to understand which paths take more computing power and when that's worth it. Arrays are a bit more limited in what you can use them for, but they are also more performant. Since this is a beginner course, I wouldn't worry about it too much at the moment. If you think arrays and lists and it just feels confusing and I don't really know what to do when, eventually that will become more apparent and you can just use lists for now. That's fine. Or just use arrays and live with the fact that you can't add new indexes during runtime. To give you an example of when lists would, for instance, be useful instead of arrays, in my own game that I'm working on, I've got a monster spawner where I use an array to set which monsters will spawn, because that doesn't need to change during gameplay. But the monster spawner itself is an object that has a list on it, which also keeps track of which monsters it has spawned. And those monsters add themselves to that list during runtime whenever they are spawned. So that way, the spawner always is aware of what living enemies are around it, and that list will dynamically get bigger or longer depending on how many enemies it has spawned and how many you have killed. So when that list eventually doesn't have any objects in it anymore, it knows you've gone through this wave of enemies, it's time for me to spawn the next one. And that next wave of enemies is an array. In that same game, I also have a targeting system where I have a list of all the enemies within a certain range around my player characters at any given time. That list gets regenerated every single frame, and sometimes that might be no enemies, sometimes that might be 10 enemies. So that's why it's a list. On the other hand, I have a system where you can cycle through a number of different weapons on your player character, and I'm never going to add more than 7 weapons. So that can be an array. A very quick video here about parenting objects, and if you're following along with the series, you've actually already seen it happen on this very object here, the canvas. You see it's got this drop-down menu. That's because everything under this canvas is actually a child object of the canvas. A better example are actually the buttons. They get generated with a child object in them already. And what does that mean? We can see this text and we can move around the text itself. But then when we move around the button, the text is stuck to the button in whatever place we put it in as the text. So if I put it here, it follows around the button. It also does that for things like rotation. It doesn't just copy the rotation from here, it actually moves as if it's part of the same object. So if I rotate this around its center, the button text will rotate around like that. So let's just show you that real quick. As you can see, it doesn't just copy the same rotation information, it actually moves with it as if it's one big rigid object. This, of course, is very, very valuable, because if we go back to our little square here, or our main camera rather, we've had this square that can move for a little while now, but if we put that in the center of the screen and we drag this camera onto our square object, it will now be a child object of the square, meaning that it will move with the square. So if we move the square now, we can see the camera moves with it. Let's just quickly put down a couple of sprites here in our game world to have a little bit of context of where we're moving towards, because that holds true in game as well. As you can see, because the camera is moving with us, we can see that we're actually moving around in the game world. If you want to access the parent through code, which you're going to want to do, you're going to want to set or clear parents through code, or just see what a object's parent is through code. The way we do that is through a transform variable. It's part of the information that you can find. Of course, we first get the component for its value, but then we can, for instance, say transform dot parent equals, and now we need to put in another transform. So let's make a public transform call it parent. And now when the game starts, our player will be parented to whatever transform we put into this field. So let's say we want to parent our player to this circle. What we do is we go into our square, we see our player movement, parent field, and we simply drag that over into there. And this way we can set parents through code rather than only through the editor. And now let's go scene view and game view side by side real quick. We can see if we move this, we'll parent to the circle. If we rotate the circle, we can see the player rotates around it. And that's already a very, very useful way to use this. Is if you want to have one object circle around another object, what we can do is we could, for instance, let's say we want to have a circle that circles around this circle. So we add this, and then if we make a empty object, it's just a object with nothing on it other than a transform, and we then parent that circle that's going to have to rotate around the center circle here to that empty. Now this empty does nothing else other than just rotating around in an orbiting fashion. If you look at my own game, we have a camera with a camera holder object, and that camera holder object itself is actually stuck on the player. But when we turn this around, you can see that makes the camera orbit around the player, which in gameplay looks like this. So that's a quick little video to cover how parenting works in the Unity engine, and not only in Unity, really in any program that you're going to see like parent-child relationships in, this is how it works. If you're looking to work in After Effects for any reason, to like make a fun little animation for your game, and you run into parent-child relations, this is how it works. Collisions. Even if you've never made a game before, you probably know and understand that word to a certain degree, because every game needs a collision system to make literally anything work. I've set up a little scene here with this red line around my player, and we're going to make something that when we touch those red lines, our scene will get reset. We'll reload the level. Then we'll also end up making a key that in the next video, we're going to make a door that'll check if we have that key so that we can move out of this little room. For now though, if we don't have any code, the collision itself already works. We can't exit out of this because the walls that I've made here, those are these 4 squares, all have a box collider 2D, and my player here also has a box collider 2D and a rigid body. Just putting those components on these objects already makes the collision itself work perfectly. From here, we're just going to add some extra code on top of that. And we're going to do that for the time being in our player movement, because our player movement script already exists and it's relatively small, so it can take a little bit more code before it starts becoming unreadable. So Unity comes with a couple of functions that you can use for this, which is fantastic, and those are called onCollisionEnter. You've also got onCollisionStay, onCollisionExit, and you've got a 2D variant for all of those. Of course, we're going to be using the 2D variant for onCollisionEnter. Then, since we're going to be reloading the scene, we need to be using Unity engine.scene management. Otherwise, we can't access the loading and unloading of scene. And in here, we're simply going to just use that scene manager.load scene. And in order to load a scene, we need the scene's name. So the way we get our current scene's name is we use the scene manager.getActiveScene, which is a function, .name. And that's all the code there is to it, because this onCollisionEnter 2D will fire every single time there is a collision 2D event. So whenever we collide with something, this will run. Now, in a real game, things get a little bit more complex, because you're probably going to want to check what you've collided with, because you don't want this to run on your character every time you collide with the ground. You only want this to happen when you collide with a bullet or with an enemy or with a whatever. So this is not very useful for a real world purpose, but for a example, I think this will do fine. So now when we run into these walls, we can see the scene reset. Now, time to make a key. So let's add a new sprite. Let's make it a capsule. Why not? Make it a little bit smaller. And let's make it a purple. To this, we're going to add a capsule collider 2D to make it fit the sprite properly. And this one, we're actually going to change into a is trigger. The difference there being we can just go through this. It's still noticing that there's a collision event there, but since it's a trigger and not an actual collider, it will not stop us from going through it. The moment I disable this is trigger, now it's just a normal collider and it works like usual. Of course, the on collision enter 2D is not the only thing. We also have a on trigger enter 2D, which does what you might expect it to, namely that being fire every time you get into a trigger collider. For now, we're just going to make this delete the key and change a bool within our own code. So let's make that bool. So bool has key. When we get in a trigger, we first set has key to being true, and then we make a game object variable for the key, which is equal to collision.gameObject. Then we simply destroy the key. And now when we enter the trigger, we can see the key got destroyed. And if we go into our player script, we can't see the value for all of our variables. If you come up to the top right corner here, we can change this from normal to debug, which will let us see all of the variables, even the ones that are in public. So let's do that again and keep an eye on the has key variable, because now when we collect a key, you see that becomes true. That's something that we can then use in the next video to make a door that only will let us go through it when we have the key. Today we're talking about one of the most important things to elevate you from writing very simple instructions in a script to being able to build a proper system and program a game, and that is if statements. Last time we talked about collisions and we made this little function over here which would reset the game whenever we collide with a wall. We're going to comment that out real quick so that it doesn't work anymore, because we're going to do something different today. We're going to change this bottom wall over here to have a opening, and we're going to be putting a sort of door in between here. So let's create that door and let's make it a different color and match it with the color of our capsule here, our key. Now, we can't move through this because it's got a collider on it, which makes sense. But we want to have a system where if we pick up this key and then go to this door, this piece of the wall, which is our door, will be removed. We can do that by adding a new component, and we're going to make a script and we'll just call that door script or something like that. In that script, we're going to need a reference to our player movement, and we'll just call that player. And we're going to need to make that public so that we can give it a value in the editor. We don't need the start or update functions, because what we're going to do is we're going to put a on collision enter 2D, as we learned about in the last part. And here we're going to get into the if statement, because when the player collides with this object, we want to check whether or not the player has picked up the key. And if you recall, we have a Boolean variable in this player that's called has key. So with our understanding of variables, what we can do is we can get this variable here, which is going to be our player. We can check if the bool in that variable is set to true, and if that's the case, we'll just delete this object. We can simply do that by typing if and then two parentheses. In the parentheses, we're going to put our condition. So our condition will be player dot has key equals equals. We'll get into all the different operators that we can use in a moment. If you want to check if something is exactly equal to something else, you put two equal signs. And we want to check whether or not that is true. If that's the case, we add these little curly brackets, and then any code we put in between those brackets is going to run only if this is the case. So in this case, this would be just destroy this game object. In the Unity editor, we can now see that on our door script, we have a field for the player. We can drag in the player. It'll automatically find the proper script. And now, if we try to go through here, it doesn't work. But now that we go pick up the key and go through it, the door gets deleted and we can move through. After the if statement, we can also put an else statement. So if this is not true, we'll run this code in between these two brackets instead of the code in between those two brackets. So we can print a line, get key, dumbass. And now we'll open the console And you can see that if we collide with it now, it says get the key because it's executing the code in the else portion. Now, there's a lot of different things you can check in an if statement. We're going to go over a couple of them. The first one is being exactly equal to. For a bool, this is the only one that you can use. It's either true or false. So that is just two equal signs. Little side tangent there. If you're just checking for a bool to be true or false, you don't actually need to put that there. It inherently knows that, oh, this is a bool. So if you just put in the bool variable there, if this is true, it'll do it. If this variable has a value of false, it'll do the else. In much the same way that we can check something being exactly equal, we can also check if it is anything but equal. And that's just done through replacing this first equal sign with an exclamation mark. So now it's checking not equal to. So just think of this little thing in an operator as just being the word not. So now we're checking if player has key is not equal to true, then we do this. Meaning that if it is equal to true, then we do this. So it's just a inverter. But we can do much more than just checking bools. We can check numbers. So let's real quick make two public ints. Let's just call them number 1 and number 2. And we can check those two numbers against each other. You can also do this with floats. I'm just going to do it with integers for now because why not? So we can check if number 1 is less than number 2, we destroy this game object when we collide with it. But if number 1 is not less than number 2, meaning that they're at least equal or number 1 is actually larger than number 2, then this will be false and we'll do the else. Of course, you can also check the opposite if number 1 is larger than number 2, and you can check for both versions if it's smaller or equal to or larger or equal to. And again, same as with the bools with the numbers, you can just check if it's exactly equal to or if it's anything but exactly equal to. And with this little trick, you can now suddenly start making systems that make decisions based on information given. Now that you understand this, we can make things that are more than just when this happens, do this. We can put a check in between. When this happens, check if something is the case, and depending on what the situation is, do one of a number of different things. But what if we need more than just a if or else? Well, we can actually put more if statements after this else statement. So we can go else if and then put in a new if statement and chain those together as long as we want. In certain situations, that is preferable. It can get a little sloppy and very hard to read though. So say we have a larger amount of keys and every time we collect a new key, a new door opens or something like that, right? We can check if number of keys is equal to 1, open the first door. If number of keys is equal to 2, open the second door. Check and check and check all these else if statements. But instead what we can do is we can delete all of this and we can put in a switch statement and then parentheses the value of whatever we're going to be checking. In this case, let's put in number 1 for that. And then those brackets as well. And you can see it starts with case 0. We can just print something out because we don't have anything that needs to open up. So we can just say print you don't have a key yet. And then after that we will break, because breaking out of a statement like this just means that anything after this is not going to be relevant. Now, if the case is 1, for now we can just print out you have 1 key. Then in theory, you can put in some code to open door number 1. And again, at the end of it, we break. Then we put in case 2 and you get the point. We can print out you have 2 keys. We open door number 2 and we break and we go so on and so forth. These are the most basic and straightforward ways to execute code based on conditions given. And now that we understand this, we are ready to actually start going towards making a game. We're starting to make a real game. Now that we understand variables but also if statements, we're ready to start making actual gameplay. But there's one last very important thing that will help us make that a bit easier. I've made a bit of a level here. We're not going to get into the tile map system in Unity within this tutorial series, I'll make a separate video on that at some point in the future. But we pretty much have the same setup that we had before. We have the key over here, we've got a door over here, but now we just gotta go get it through a bit more of a maze. I'm also going to be adding a new diamond shape in here, and we're going to put that in as an enemy. So let's make that blue, or maybe green. Let's make it green. And today we're going to be talking about these two drop-down menus up here, that being the tags and the layers, and when to use which one. You can give every single object in your game a certain tag. As you can see, there is a number of default tags that Unity comes with, but you can add your own tags, and in this list here, we can add a tag for enemy. And in our player character, we can put in a tag for player. And we could even put in a tag for the key on the key. And tags can be used in code to identify a certain type of object without having to go look through all the components on a object to see if it has a certain type of script, right? Because right now, this enemy isn't going to be doing anything. So it doesn't need a script on it. We do need to set it to being an enemy tag. But now, even without putting a script on it, we can actually run code to check whether or not we're colliding with an enemy. Because we're going to give this thing a box collider 2D, and we're going to set that to being a trigger. We have two different things that do triggering events, right? We can collide with the capsule, which will set our has key value to being true, and then delete the key itself. But we don't want that to happen when we collide with the enemy. So in our onTrigger 2D, we're actually going to put in an if statement, and that's why I wanted to talk about if statements before getting into this. Because we're going to be checking if our collision, which is the thing that we're colliding with, .tag equals, and then we can put in a string, and we'll check whether or not it's a key. If it's a key, we just do the code that we already made, and then we return, meaning that we are going to not run any other code in this event. But if it's not a key, then we're going to put a else if. We'll check whether or not it's a enemy. And if it's an enemy, we'll run this bit of code which resets the scene, which we talked about before. Now, if you've seen the last video, you might be thinking, hey, didn't you say that this is a sloppy way of doing things? And yes, it is. I just wanted to show you this before. Now we're going to replace this with a switch statement instead. So we're going to switch on our collision.tag, and we'll put in case key, and at the end we'll break. And then we'll put in a case for enemy, which will reload the scene, and then we'll break. It's a much better way of doing things than using a load of if statements. So now we can see, if we run into that, it resets the game. But if we go up here and we go to collect the key, we just collect a key, and that's because of the different tags that those objects have. But now, what's the difference between those tags and the layers we have? That's quite simple. Tags are just for identifying the type of objects that we're talking about. Layers are specifically for collision-related things. So we can put these walls on a layer that we can just add here. Let's use layer 6. Let's call it wall. And now we can add the walls to being on the wall layer. These are all separate objects. Again, I'm using the tile map here to easily quickly make levels. Different video for a different day. Let's make this door that we have here a different layer as well. So we can, on layer 7, call that one door. And let's make one more thing that will be a pitfall, a trap of sorts. So we can go into our sprites and make a new square. Let's make this one black to represent being a bottomless pit. Give it a box collider 2D so that it has collision. And then make a new layer for it, and we'll call that trap. Set its layer to that newly made trap layer. And let's put that over here in the corner for testing purposes. And with all that, you could in theory now check whether or not the layer for the collision is trap or not when you collide with something, and do something based on that. But how does that differ from using tags? Well, and that's the interesting bit, this is not what you should be using layers for. Layers are specifically designed to be used for collision-based stuff. So if you come up here into Edit, project settings, in the Physics 2D tab, we can now see that the default layer interacts with all of these layers. So if we disable the trap layer in our default row, and our player is set to being default, there won't be any collision between these layers. But everything else still does have collision. Now, for a trap, obviously, that doesn't work very well. But if you have certain elements that need to be able to interact with something that's not the player, or only the player and not other stuff, you can make layers ignore each other in this way. If you're doing raycasting, for instance, which is a slightly more advanced step, but you can mask out which layer you want a raycast to actually look for. I'm not going to go too deep into the functionality of layers and collisions and physics and stuff like that, but I wanted to include layers in this video real quick to show you how they differ from tags. For the time being, most of the functionality that you're going to want to be using at a basic level, you're going to want to use tags, checking, is the tag for this object an enemy? Is it a key? Is it a trapdoor? Because that is realistically what you would do here, is we would go back to the project settings and re-enable this real quick. And instead of using a layer here, we can just set this back to the default layer. We would actually just put in a tag for being a trap and just set this as the trap. Because there's nothing different between the way we have to check for the collision. So there's no reason to use a different collision layer. So if you just set this to being trigger, we can then just include this as a new case, which does the same thing as the enemy case. And now you can see that it works the same way again as it should. So that is how tags work on game objects, and a little introduction to how layers work as well. Again, I'm not going to go into them too deep right now because they can be confusing and bothersome. And for the most part, unless you're doing things using physics, anything that you want to do with layers, you're probably better off using tags. Let's make a real quick video here about prefabs, because we've been walking around with all these game objects and you might see some assets here in my assets folder which really confuse you, and that's because these are two prefabs. A prefab is like a game object preset. It's a prefabrication for a game object that you can then put countless versions of in your game. So how do you make one? It's very, very simple. Let's just select our key that we have over here, change its name to being key, and all you have to do is now drag it into your project folder. And there we go, we have a prefab for a key. And now we can just drag this into the level as much as we want, and now we have duplicates of that key. But if we double click this asset, we can now change or add things about this prefab without having to go through and change it about every single instance of that prefab we have in the game. This is also how we can spawn in entire game objects, because if we want to spawn something in, we use instantiate, but we need a game object reference for that, and if it doesn't exist in the world yet, we can't spawn it in. You can use a prefab, however, for that, because as you can see, we'll just quickly make a public game object key just to show things off, and we can see that this key needs a game object, and we can put in prefabs in there. Now, it's probably a good idea to make a prefab of our player character here as well, so that we can easily drag and drop them into different levels. Now, the reason that you're seeing these walls and doors in my asset folder as prefabs is because I've been using them with the Unity tile system, which again, different video for a different day. Big upside to that is if I just come in here, I can just change one little thing about this prefab, like let's say we actually want to make this blue, and now if we come back here, all my walls are blue, even though these are all separate game objects, which is not an ideal way, by the way, of building a maze like this with a tile system. But it goes much further than that, right? Because we can change the color of our doors as well. Let's make them a little bit more of a door color, so a bit more brown, maybe. But you can see that this prefab also has a script on it. So if I want to add extra functionality with a new script on this door, I just do it in the prefab, and then And then every door in every level that I'm using instantly will have that new script with the new functionality on it. Now, if I need to put in some variables and give them values, I do need to do that on an individual basis if I'm not doing it through code, obviously. But this both allows you to reference game objects that don't exist in your world yet, as well as smoothing out your workflow to make things a lot more scalable. Let's talk about loops, specifically for loops and for each loop, because while they're very similar, there's minute differences between the two of them. So far in this project, if you haven't been keeping up, that doesn't matter. This can just be watched on its own. We've had this key that we can pick up, and I'll just show you, actually. We can go pick up this key, and it will destroy the key, and then it will enable our hasKey bool, which will then allow us to go through one of these doors, at least in theory. At the end of a previous tutorial, I changed up the code for the doors, so that doesn't work like that anymore. Doesn't matter, we're going to be changing it anyway right now. Because we're going to be changing it into a system where if we pick up the key, it will delete all of the doors that are linked to that specific key instead. So how do we do that? I've already made a key door opener script. It's a very descriptive name, I know. And if we open up this script, it's empty. And we can make a public game object array, and we'll call that doors. Now, in the Unity editor, we've got this array here, and we want to delete 3 different doors. So we can just go select this door over here, and we can drag in these 3 doors into these game object slots. Now that we have a reference to all these 3 doors, we can influence them. But how do we all influence them at once? That's where for loops come in. So let's make a quick function here called void delete doors. And in this function, we're going to make a for loop. So we write for and then 2 parentheses. Actually zoom in so that you can see a little bit better. And the first thing we do is we initialize a variable, and we're going to be counting the amount of loops we use. So that will be an integer. Traditionally, we call that integer I, but you can really call it whatever you want. And we'll set that equal to 0. Then we separate this with the next bit through using a semicolon, just like you do with the end of a line of code. The next part is going to be the condition. So as long as this condition is true, the loop will keep on going. Usually we compare the I variable that we just made to a different number. And in our case, that will be our doors.length. So however long the doors array is, that's how many times we're going to loop through whatever code we're going to create here. Then another semicolon. And then the last bit we need is the incrementer for every time we loop through. Usually this is just I++, meaning that I increments by 1. All of this, you can make any variable you want here. You can use any condition you want here, and you can use any amount of incrementation you want here. This is more or less 99% of the time what you're going to use though. Then we put on 2 brackets and we put in the code that needs to loop within those brackets. And for this, it's actually pretty easy, because what we're going to do is we're going to just say destroy, because we need to destroy one of the objects. And the predictive text here is entirely correct. We're going to destroy doors and index number I. Let's go over that real quick so that you really understand what we're doing here. We've gone over the destroy function before. We're going to destroy the game object of our variable doors, but since doors is an array, if you haven't seen my video on arrays and lists, go watch that one for a little bit more context. Because as we know, arrays have a number of indexes. So we need to specify which index, which object that's stored inside of that array is going to get destroyed. And that will be the index that's equal to our current I value. So our current loop through. Meaning that the first time we loop through this is going to destroy index 0 out of doors. Then it checks, okay, is I less than doors.length? Yeah, it still is, because doors.length is 3. So it will increment I and go through this again. And now it will destroy the doors I, in this case, is 1. So it will destroy index number 1 in our game object array. Then it will check again, is I less than doors.length? Well, doors.length hasn't changed, it's still 3. So it will increment again and go through until this isn't true anymore. So if we put a on trigger enter 2D here, and we just put in that delete doors function that we've just made, and I comment out some of the old code that we used before, we'll be able to see that if we run into this key now, all 3 doors instantly disappear. It doesn't delete a key though, because I just commented out that code. So you can just go back into your delete doors function, and under the for loop, then we can just destroy this game object. So as you can see, now it will destroy all 3 doors and itself. That's a for loop. Now we're going to delete that, and instead we're going to make a for each loop. A for each loop does the same thing, but it's specifically designed to work with arrays and lists. A normal for loop you can use for a variety of different situations, because you initialize your own variable and you set your own condition and you set your own incrementation. A for each loop simplifies it all for you, as long as you're working with an array. So the way we use that is we say for each game object, and then we give that game object a name, let's say instance, and then we specify in which array. So for each game object in our doors array, we will do something, which in this case is just destroy that instance. And you'll be able to see that the functionality is exactly the same with a slightly different piece of code. In reality, it's not even that different, but you can see this looks a lot more straightforward and it takes up a lot less space. You have to do a lot less manual stuff. So for each loops, they're really, really nice to use. Still doesn't hurt understanding how to and when to use normal for loops as well. A downside to the for each loop though is, as you can see here, I'm trying to write to our instance variable, our game object here, and we're getting a error because of it. Property or index or game object transform cannot be assigned. It is read only. So you can't write to these variables. You can only read from them. And since you don't have a I variable that's incrementing through every single time that you can access, it's also a little bit more difficult for a for each loop to count at what point in the loop it is. If you want to make a loop that every 10th time, for instance, adds something to your score, it's much more straightforward to do that with a normal for loop. But if you just need to have a list or an array of objects destroyed or assigned to a certain place or whatever, that's where for each loops become very, very useful. It's simpler, it's much more straightforward, but it's also slightly less flexible. We're going to talk about some stuff to do with UI, user interface, graphical user interface, whatever you want to call it, because it's a very important part of your game, most likely. And there is a lot of depth to making UIs, and we're not going to get into all that. We're just going to go over the basics today. You've already seen me do some UI stuff if you've been following this entire tutorial series from the start, and that's when we did the whole button thing at the very beginning when I was showing off how to code. Today we're going to go into that a little bit more. So the way you make a UI in Unity, you start by adding a UI element here, and we're going to add a canvas. And you'll be able to see there's a couple of lines added here, which is really weird. Well, if we double click that, you can see that this is how big the canvas is. In my opinion, honestly, this is a little bit annoying the way it works with the canvas just existing in your scene instead of being a separate asset. There's nothing much I can do about it. This is how it works. The upside to this is because it's a game object in your scene, it's very easy to make references to other objects. And in this canvas, we can just put anything in this UI tab. So if we want to put in an image, we can put in an image. And in that image, we can put in any sprite. I've got a sprite of a key here. We can just put that in. And now we have a UI element for a key. Let's put that here at the bottom left. And now if we open the game, we can see we have an image of a key in the bottom left. And objects on your UI, just like any other objects in your game, can have a bunch of components. You'll note it has a rectangle transform rather than these game objects which all have a normal transform. And that's because it needs to be aware of how to rescale up in different resolution. In general, just keeping with the default settings here works fine. You can give it a number of different anchor points. So we can say scale with the center, scale with the left side, scale with the bottom left side, or whatever. In general, keeping this the way it is, unless you have a very specific reason to change this and you understand why you're changing it, just keep it at scaling with the center. The moment your game is going to be displayed on a widescreen monitor that's like 21:9, that might become an issue. But my hot tip there is just don't make your game support widescreen and you'll be fine. Nobody's playing on widescreen anyway. Don't worry. Which brings me actually to another thing here, and that is the canvas scaler on the actual canvas object that we added as the first thing. We can select a UI scale mode. We've got constant pixel size, which just respects the actual pixel size of the images that you're putting on your UI. So if your image is 200 by 200 pixels, it's going to be displayed smaller on a higher resolution screen. If it's on a 4K screen, it's going to be really small. If it's on a 720p screen, it's going to be really big. And your UI look is not going to be consistent. It's going to be consistent in its sharpness, not in its size. Then we've got scale with screen size, which means that it's going to stay the same relative size to your canvas, no matter what the resolution is that you're using. And then we've got constant physical size, which, don't worry about that one, you're probably not going to use it. So we've got this set to scale with screen size. Your reference resolution, generally speaking, you probably set that to 1920 by 1080. A lot of people might be playing in 4K, which is fine because it will just upscale everything. You can just set this to 4K if you want to. It doesn't really matter. Anyway, all of your objects on here, you can add scripts to as well. So let's see, we can get a key gathered script or something like that to display whether or not this key has been gathered. We can make a public color not gotten and a public color for gotten. Then we also want a reference to our image from Unity Engine UI. It'll automatically add it on top here. If your code editor for whatever reason doesn't do it, in order to reference pretty much everything about UI elements, you're going to need to be using Unity Engine UI. So for being able to reference an image variable, you need to be using that. Let's call that image key. Then in the start function, we can set key to get component image, and then our key.color will be set to not gotten. We can make a public void getKey function, and in that we set the key.color to being gotten. The not gotten color will be a bright red, and the gotten color will be green. Then on our key, we're going to go to our key script that we made a little while ago, and there we'll make a key gathered variable. We'll make that public. This is all part of the things that we've seen before, so I'm rushing through this a little bit. Realistically, you want to do this with Unity events, but we'll make a separate video on Unity events. We'll call that UI keys, and then when we on trigger enter 2D here, we'll say UI key.getKey. I'll actually put that before delete doors, otherwise this script will delete itself before it can run that code. We'll drag on this image to our UI key variable here so that it has a connection to the UI component. And it's a rather dark image, so it's kind of difficult to see, but right now it's got a red coloring to it, and then when we pick up the key, we can see it ever so slightly changed to being a green coloring. So in that way, we can influence UI elements like any other game object really in the game. The only difference is it has to be on a canvas. Some other things that we can add are UI buttons. So if you go to UI, we've got a button, which is part of TextMesh Pro. These buttons have a child object, which we've talked about in the past, child and parent relations, which we can type in any text we want. So press to open doors. And if we go back into the button, we have a on-click event here. And again, we'll talk about events a little bit in the future, but for right now, we can just add something to this list, and we can pick any object in our scene. So let's pick up our key, put it in here, and then we can run any function out of any of the components on that object. So we can key open door, and then as long as this function is a public function, we can now see it here in delete doors. which now will, when we press this button, run the same code. You'll note though, maybe not, that the key didn't change color, and that's because it's not actually in that function. It only runs whatever is in this function, and the key changing color is part of the triggering event, not of the actual function to delete the doors. And to round off this video is we're going to add one more thing, and that's going to be a Text Mesh Pro. There's two types of text in Unity. There's the old legacy text system that only exists still in Unity to not break old projects. Never fucking use that. We've got Text Mesh Pro. It's got a lot more options to it that you can use, and we can, just like normal text, influence this through code as well. So let's add a component and say score counter, for instance, here. And the way we reference the text on the Text Mesh Pro is through a Text Mesh Pro UGUI variable, which is quite a mouthful. But as you can see, and the reason that I wanted to discuss this is that in order to use that variable type, we need to be using TM Pro. And let's call that score. And let's do the same thing that we did at the start of this tutorial series. Let's make a public int score count. And now we want to set the text in our Text Mesh Pro. So we say our score dot text because we want to reference specifically the text. We can change a lot of things about a Text Mesh Pro UGUI variable, like its font, like its material, like a lot of different things. So we need to specify that we want to reference the text here, and it already autofills the rest for us. Is going to be equal to our score count, which is our integer, dot to string, so that it can actually be used as a piece of text. Then let's also make a public void increase score with a integer for amount to add, and our score count will plus equals amount to add. This is all stuff that we've been over before. And before this can work, we need to give our score a value of getComponent Text Mesh Pro UGUI in the start function. Now let's make a new button again, as we have done before. We go down to UI. We scroll down here to button. In its child object, we go to the Text Mesh Pro in there, and we type increase score. Don't worry too much about these arrows that you can see here. That's for navigational purposes if you're using a controller. That's a little beyond what we're doing here right now today. Let's make this button just a little bit larger so that the score text can fit inside of it. Then we go to this button's on click event. We get our Text Mesh Pro. We add a action there. We drag our Text Mesh Pro over. We check our score counter script and go to the increase score, and we increase it by 1. And now you'll be able to see, now we can see our score is 0, and when we press the button, it increases. So that's in a nutshell how building a basic UI works. You make a canvas and you put UI supported elements under that canvas as child objects. You can scale the canvas in a number of different ways. You can give different pivot points to different objects on that canvas, which shouldn't matter as long as your game is being played on a normal 16:9 screen with a reasonable resolution. Unity events, it's a very powerful and nice tool to have, and today we're going to talk a little bit about it. So we've got this little scene over here, and in a previous tutorial we made a system where if we pick up this key, it goes through this array and deletes all of the game objects in this array. But what if instead of always destroying an array of objects, maybe sometimes when we pick up a key, we want to create an object, for instance creating a bridge or something like that. Do we need to make a whole separate key, a whole separate script that does everything exactly the same except what happens when we run into it? Well, for something as simple as a key, that probably doesn't matter that much. But if you've got a much more complex script with a lot of different things going on, it's not particularly a good idea to make a duplicate of that just for one tiny difference. Because if you then need to change something about that existing code, you suddenly need to change it in two places. And as far as coding goes, the rule of thumb is always, if there's a way to not have to duplicate your code, you take that way. So instead what we're going to do here is we're going to change this into a Unity event. And a Unity event is something where we can run a specific function from any object in our scene, and which object and which function that is can be chosen on a case-by-case basis. So instead of using a game object array for the doors here, what we can do is we can delete this, and instead we can put in a public Unity event, and we call that something like on pickup, because in the end that's what we're doing, we're picking up the key. And then we can just kind of run that like a function in any of our code. So we have our onTrigger enter 2D here, and in that we used to run the delete doors function. What we can do instead is we can just say our onPickup dot invoke, and now it will run any code that we put into this event inside of the Unity editor on an instance by instance basis. So let's go to our door script real quick here, and let's make a public function that will delete the door. That'll just destroy this game object. And now when we go to this key, we see a onPickup event in which we can add things that need to happen. So we can still just go through and say in our grid here we have these doors. We can still say for each one of these doors we can just drag them in here and create the function for delete door on every single one of these. And functionally, ignore the UI, we did that in the last episode, this will still do the same thing, right? But the huge upside here is that we can make a second key, which we can just drag in through here, put that on the other side of the door, and we can put different code on this version of the key. So we can put in a key that we can pick up, and maybe this key increases our score, right? So we have a score counter here, which is this object. So we can drag in our Text Mesh Pro, and instead we can go to our score counter and increase our score by 5 when we pick up this key. Now, this is the same object for all intents and purposes. It's just running different codes on its event being triggered. So this one doesn't increase my score, but it deletes the 3 doors that we have. And then when I pick up this one, we see that my score increases by 5. So where we can make a game object that exists out of multiple components and have a very modular system in that, events allow us to do that one step deeper with specific code that needs to be executed. So we can have these same components run different code on a per instance basis. This makes designing your levels a lot smoother because you don't have to make references in every single script to every single other script of every potentiality that it could influence. You just make an event, and instead of putting the code for deleting the doors on the key, you let the key alone. You keep that very, very minimal, and you put the code for deleting the doors on the doors themselves. Then that event on the key can reference maybe that door, maybe a score counter, maybe a bridge that needs to be created. Maybe it can trigger a enemy spawner, and when you pick up a key, it can spawn enemies. It can do all these things in a row. It can delete a door, lower a bridge, and spawn enemies. And you are, as a designer, very free to quickly add in functionality to a specific instance of a specific object in your game world. So far, every single time we've made a function, we've made it a void return type. And I made mention to that a little bit earlier on, where every single function we have, even the ones we made ourselves, are always void types. Here again, public void got key. And I want to cover what else you can put here, because it's actually really, really powerful. So it's kind of hard to come up with an example within the limited context of this project that we've been working in. So I'm going to explain it to you first, and then I'm going to take you over to my own game that's in development and show you some of the scripts that I'm using return types in for functions in that. So what we can do is, instead of putting in void, we can put in literally any variable type we want. So let's start by showing off a bool, and then we can say does A equal B, giving in 2 floats, a float A and a float B. We now need to return a value. So we use the word return, and then we check A exactly equals to B. So it will now compare A and B and return the result of that. What does that mean? Well, now if we make a if statement, instead of putting in a condition directly or putting in a bool directly, we can actually put in this function and it will work as if you're reading a bool, because that is essentially what you are doing. So we can say does A equal B? We need to put in parameters. So let's say 1 and 7. Well, this will never run, obviously, because 1 is not equal to 7. But here we have a function that the if statement goes, okay, this is a bool function, so let me go get that. A is 1, B is 7. We're going to return the result of comparing the two of them. Oh, that's false, so this will now be read as false. For something as simple as this, that doesn't seem like it's worthwhile going over all that headache. And that's exactly why I'm going to take you into my own game projects real quick to show off to you some instances of where it's actually useful. Because in a small context like this, yeah, it probably is not worth the headache to do this. But here we have a function that is a public static float. Again, we're finally covering the return types. I will cover static classes and functions in probably the next video. But this is a return type float. So we've got a damage calculation with a couple of things being put in here, that being the attack strength, the defense strength, and a type system, much like you would have in something like Pokemon. And we have a little bit of code here saying if our attack strength is minus our defense strength is less than or equal to 0, we return 1 to make sure that it never can deal negative damage, so healing the opponent. Else, return attack strength times get type effectiveness. Which, now that I'm explaining this out loud, actually has an issue with this code. I'm not going to explain it to you. If you can figure out the issue with this code on your own, leave it down below in the comments. It's a nice little bit of homework for you. But here you can see we have two different potential returns. We can either return 1 or we can return the result of this calculation. And this get type effectiveness by itself, is a little bit down here, is also a float function. So we've got this whole list of code here, which compares the attacking type and the defending type, and returns a multiplier, either 1, 1.5, or 0.5, that can be used just as a number in a multiplication over here. But even as you can see in this class over here, a lot of what we're doing here still are void functions. Most of it is functionality that just needs to do something and doesn't need to return anything. We're going to go over static functions and static classes really quickly. So we're here on my own project, and I'm going to open up the combat script, which you've seen before if you've seen the last video, and that is a public static class. What does that mean? Well, you know how most of the classes that you make, you then put onto an object and you make an instance of that object. That's the heart of what object-oriented programming is all about. Static classes don't do that. There's only one of these that exists. And you don't need to instantiate it within your game world. You can at all times reference it. It's kind of like all of your other objects are parts that build a house, whereas a static class is the foundation. It's always there. You don't see it, but you can always go back to it. You've certainly used static classes before. You haven't made any maybe, but you've used them. Remember when we used mathaf to maybe like round a certain number? Well, I'll tell you a little secret. You can see that all of the functions that we see in here are static functions. So that's what that does, is even though we don't have a reference to a mathaf object, matter of fact, you can't even make a reference to a mathaf object. You can directly use the functionality that is written in that class. So in much the same way, this combat is a static class. So I can type in combat dot, and my damage calculation and my knockback calculation methods that I've made are available in any script anywhere. Which is very useful, because the thing here is we've got a damage calculation and a knockback function, and these can be used to damage a player because he got hit by an enemy, or damage an enemy because he got hit by a player. The math behind all of that is exactly the same. They both go through this function in this static class. The same with the knockback. The player gets knocked back, sometimes the enemies get knocked back. With knockback specifically, there's a bit more to it as well, because obviously when the player gets attacked, or when an enemy gets attacked, they have knockback. But what if you have, for instance, I don't know, just say something like a water spout on the floor in one of your levels, which also needs to knock back the player when they step on it, right? We've got a lot of different potential situations wherein we need to use this exact same code. So we put it somewhere else in a static class so that a lot of different scripts can easily reference it without having to make a instance of it in every single level that then has to be linked to every object that could potentially want to at any point in time ever use it, because it just becomes a massive headache. Now, there's a little nuance here that I want to talk about real quick as well. And that is, this is a static class, so everything in this class, including variables, we can make variables. We can make a static float and just call it number. Everything in this class has to be static because there can only ever exist one of them. If something is not static, it's going to need an instance, which necessarily is not possible because everything in here has to be static because there can only be one of them. But that doesn't necessarily go the other way around. For instance, I have my level manager, which is the game object that manages a lot of different things going on in the level. This could by all accounts be a static class in and of itself, but I've opted to not go that route, at least not at the moment. And that is because if I make something static, it can't be a mono behavior, and mono behavior also gives a lot of functionality. So sometimes it's a good idea to not make a class static, but you can still make the things inside of this class static, as you can see. So we've got a static game object and a static vector3 here, and all of these things, even if I had like 3 objects with a level manager on it, if I change it on one of them, it changes on all of them. Because if something is static, only one of them can exist. So if I've got 10 objects, which all share one static variable, in this case the spawn location for the player, if I change it in instance number 10, it also automatically changes in all the other instances of that object. Unlike a lot of other things in this tutorial series, it's a little hard to show this in a, well, write a piece of code and you can immediately see the feedback of what it does. I hope that after hearing me ramble for an hour and a half, 2 hours of tutorial building up to this, you have gotten to the point of abstraction where you can understand this through purely explanation. I'm going to reiterate this once again though, just so that you are entirely sure to understand this. All that something static means is that there can only exist one of them. If that's a class, that means that it's going to be part of the foundational code of your game. If it's a member of a class, that being a variable or a function, that means that every instance of that object shares the same variable. So spawn location, there's only one of them. There might be 10 level managers that all reference a spawn location, but they all reference the same one existing variable. There isn't 10 variables, they all point to the same one variable. So if I write a value to it on object 10, and if I then go to object number 6 and read that variable, I'm going to see the value that I just wrote to it on object number 10. I hope this has been somewhat clear. Again, this is one of those things that is a little bit less obvious to show off and has a slightly larger layer of abstraction to understanding it, but it does make your whole workflow a lot better and a lot easier, a lot smoother once you start understanding this and thinking, do I need more than one of these in my game? If the answer is no, you might as well make it static most of the time because it's just going to be easier to reference. Now, that being said, you can also shoot yourself in the foot with this, because initially I did everything regarding a player also make that static, because I'm only going to have one player. And while that works, and that is true, if I ever decided to make multiplayer compatibility for whatever reason, I would have to rewrite 90% of the player-related code. And that would be a massive pain in the butt. So don't go throwing statics around too willy-nilly either. Alright, so today we're making a timer, and we're doing two different types of timers. I'm first going to show you a simple way to make a timer that displays a time on screen. And that same technique can be used to make timers in your code as well, although that's a little bit messy. So we're also going to be looking into using coroutines for saying wait a X number of seconds inside of your code. So first things first, I'm going to add a TextMesh Pro here, just a little bit of text. And we're going to add a script to that that's just going to show how many seconds have passed since we started up the game. So we'll make a quick TextMesh Pro UGUI. We'll call that text. We'll give that a value of text equals getComponent in the start function. And we'll make a float for the time. And then an update, what we'll do is we'll make time plus equals, so we're going to add something to the existing value of time, and what we're going to add is time with a capital T dot delta time. So that's the time between the current frame and the last frame. Usually that's like 1/60th to 100th of a second. We'll store that in this variable here, and then we can update text dot text to be equal to a math function called floor, which just always rounds down your number. And in that, we'll put in, of course, our time variable, and then we'll make that a toString to make it a string so that we can put it into the text. And I made a mistake because setting the text is not a function. We just put in a equal sign for that. And now when we go back into the game, we'll be able to see that that text in the top left corner is just going to be a timer of how long the game has been running. So we'll see 1, 2, 3, 4, 5, etc., etc. This same ID you can of course also use in a timer for gameplay. So when you pick something up, you toggle a bool variable, which allows the time variable to start counting up. Then you check whether or not the time is greater than a certain time that you want to check. And if that's the case, you do the functionality that you've been waiting for. If you think that sounds overly complicated and messy, you would be correct. So we have a much better way of doing that. So we're going to go to the key door opener script here. And we're going to change a couple of things around because we had this event that gets invoked, and that event will, in this case, delete the doors around that key. And then we destroy the game object. So before we invoke, we're going to put in a timer that says you're going to wait, let's say 2 seconds before invoking all of those things. And the way we do that is we say we start a coroutine. And the coroutine takes in a method name, so a function, as its parameter. But not just a normal function, because normally when we make a function, we call it something like private void, like let's call it wait, right? But that's not going to work. Instead, what we want to do is we want to make a IEnumerator and call that invoke event in this case. This needs a return path. That's a little bit weird because the way we return here is we return with yield, return, new, and then we can, in this case, go for wait for seconds. Any code we put after this is going to run after 2 seconds. That would be the onPickup invoke and the destroy. And then we simply put in the invoke event. We have to use a string for the name of the method that we're going to call. And now what's going to happen here is we have the onTrigger enter2d. We already had that. We create the UI. We actually also want to put this into the coroutine, I realize now. So everything is going to go into the coroutine, which is going to start by waiting for 2 seconds and then proceeding to do all the other code. And since we have a handy timer in the top left, we can actually check. That's 5, it's 1, 2, and now it does the code that we put into it. Now, of course, you can also put in some other code before it, so code goes here. Or even within the enumerator, any code you put before the wait for seconds will happen before the waiting. So if we, for instance, say we print just a simple string called picked up. Now when we're running the game here, you'll be able to see that as soon as we make contact with the key, the message will pop up down here in the console, but all the other code will wait 2 seconds before it will run. So we have the message, and now we have the doors being destroyed. And of course we can also put in a variable there, so if we want to make a float, wait timer, and by default set that to 2, but make it something different sometimes. We can put in our wait timer here, that can be a variable, that's no problem. And with that, finally, you've reached the end of this beginner's course for Unity. First and foremost, thank you to all the Patreons that support me over on Patreon. You can see them on screen right now. If you want to support the channel for more of this type of content, you can go support me over there. And for all the more individual tutorials, you'll also be able to find the project files with my code in it over there. If you want to learn more and keep experimenting more with learning in Unity, my advice for you now is to try and recreate some games that are fairly simple. Something like Pong or Flappy Bird, both of which I have full tutorials for on this channel as well, which I'll try to remember to link down below in the description.